This problem is going to look at dividing polynomials which both have more than one term, such as the problem we have here, 2x squared plus x minus 10, a trinomial, divided by x minus 2, a binomial. And then what we're going to look at this, is like the book is doing, is we're going to treat this as a long division problem, where the first thing is we have to put them in the right spots. The first one, the trinomial, being in front of the division symbol, is going to go inside here in the dividend, and as the book mentions, this does need to be written in descending powers of the variable, largest power first, next largest, so forth and so on, and the polynomial that comes after the division is going to go out in the divisors position out here in front. And so to do the division, we treat this like regular normal division of whole numbers with a few tweaks. To start the division, we take the first term x here and divide it into the first term of the dividend, 2x squared, giving us 2x for the first part of our answer. We now need, just like in regular division, to take the 2x and multiply it out front, but in this case we multiply by both terms out front, giving us 2x squared minus 4x. And then, just like in regular long division, we now need to subtract. Now, it's fairly obvious when I subtract this first column right here that the 2x squares are going to cancel, leaving 0. Okay. When I subtract the next column, though, keep in mind what you're not going to do is add the x, the negative 4x. Remember, it's one minus the other. In effect, writing it off to the side here, that would be saying x minus a negative 4x. And what happens there is that's going to turn into a double negative, x plus 4x, which in the end is going to give us 5x. And so really, the result of doing that subtraction here should be a positive 5x. Now, some people are going to look at that and still say, well, I'm still probably going to mess that up, which is why they give you a little bit of a tweak. They say when you need to get to the point where you're subtracting, so let's go ahead and get rid of this. And so you're trying to subtract. What they're going to say to do is, instead of thinking of it as subtraction, go ahead and take the bottom row of the subtraction, change your signs. We'll take that one and make it a negative, and I'll circle the changes. This one I'll make a positive. And then instead of subtracting, go ahead and add. And the 2x squared and the negative 2x squared are still going to cancel. But x plus 4x is going to give you the 5x that we need it to be. And so whenever you need to subtract, instead, think of it as change signs and add. And just like in regular division, now that we've done that, we bring down the next piece, the negative 10, and keep going. But to get the second part of our answer, we go ahead and go back to the first term here and still divide the first term x into the new first term 5x, which gives us a plus 5. Taking that and multiplying it by both terms out front, we get 5x minus 10. And then remember, we're subtracting again, so we're going to go ahead and change signs and add. Make this into a negative, make this into a positive. Only change the signs on the bottom row. And both of these columns actually cancel. The 5 and the negative 5, the negative 10 and the 10 cancel, leaving 0. Which means you ended up with a nice 0 remainder, and your final answer is this 2x plus 5. Alright, now that one worked out nice because it had a 0 remainder. But what if we had something a little bit different? All right, let's give you another one here. Say, for instance, they wanted you to take 3x cubed minus 2x plus 5, and they wanted you to divide it by x minus 3. Well, there's an added feature to this one, and that is there's what's called a missing term. So when I go to write this using long division, it's fairly obvious that the x minus 3 is going to go off to the side, and that is in descending order. But when I write this 3x cubed minus 2x plus 5 in here, even though it is in descending order, notice how it skips from power of 3 to the power of 1, effectively skipping an x squared. And you might think, well, so what? But in order for this to work out well, not only do the terms in the dividend need to be in descending order, but any missing terms need to be filled in, which means even though there isn't an x squared, we do need to fill it in. And how do we do that? How do we add something and not change it? Well, you just add a 0. So what we're going to do here is we're going to add a 0x squared, and then the minus 2x and the plus 5, And in this case, we've actually got our missing term in there. And what it effectively does is it opens up a column to put all our x squareds. And so once we fill that in, it's basically the same as before. Divide the first term x into the first term 3x cubed, which gives us 3x squared for the first part of our answer. Multiplying that out front and writing it underneath, we get 3x cubed and then minus 9x squared. Notice how now, by putting the 0x squared in here, we actually have a place to write the negative 9x squared. Remember, we need to subtract, so we change signs and add. It's a negative, it's a positive. The 3's cancel. The 0 and the positive 9x squared are going to give you 9x squared. Bringing down the next piece, negative 2x, we keep going. Now we divide the first term x into the new first term 9x squared. And that's going to give us a positive 9x. And multiplying that by both terms out front, we end up with a 9x squared and a minus 27x. Changing signs and adding. Here the 9's cancel. The negative 2 and the 27 are actually going to give us a positive 25x. And since we have more to bring down, we'll bring down the next piece and keep going again. Going to have to move this up a little bit. Now we divide the first term x into the new first term 25x, which gives us plus 25. And once again, multiplying that by both terms out front, we get 25x, and then 25 times a negative 3 is negative 75. And once again, changing signs and adding. Here we make that a negative. Here we make this a positive. The 25's cancel, but 5 and 75 give you 80. The only thing is, there's nothing else to bring down. And so technically, we have a remainder. So not only did this problem have a missing term, which you have to be on the lookout for, but also ended up giving you something other than 0 at the end. So the question is, how do you write that? Well, some textbooks will let you just put big R 80 for the remainder, but that's not what this one wants you to do. What this textbook wants you to do to write the answer out is it wants you to display the remainder by simply taking your answer and adding a fraction to the end of it. Go ahead and make it look a little bit nicer. All right, adding a fraction to the end, where the numerator of the fraction is the remainder 80, and the denominator is the original divisor, x minus 3. And so this right here would be the answer to this problem. 3x squared plus 9x plus 25 plus an 80 over x minus 3. So an example of one that's zeroed out and an example of one that has a remainder as well as a missing term.